In this chemical reaction, we've got A and B and C written, and we're asked to write a rate expression for the reactants and products. Remember that reactants go away or decrease in concentration, so we need to put a little minus here to remind ourselves of that. B will decrease, and C will increase in concentration as the reaction progresses. So when we write a rate expression, we want to use these signs here as well as the coefficients in the balanced chemical reaction. So we've got a 1, a 0.5, and a 2. So the rate becomes minus, because of that reactant, change in concentration of A over 1 times the change in time. We have another reactant, so that's the negative change in concentration of B over 0.5 times the change in time. So I just report that as a decimal here. And that's equal to the change in concentration of C over 2 times the change in time. And we don't need a negative sign here because that's a product. So that's the answer for A. Now this next part asks us to convert. We have a rate in terms of C of 0.025 molarity per second, and they ask us to compute the rate in terms of B, the rate in terms of A, basically how fast or do those increase or decrease. So what I recommend doing is converting from moles of C to moles of A or B, and then worry about the sign later. So we have 0.025 molarity per second. Molarity can be written as moles per liter, and we're talking about the product C. So moles per liter is molarity per second. And we want to convert this to B here. So there's 0.5 moles of B reacting as 2 moles of C form. And go ahead and compute this out. And we get a value of 0.00625 moles of B per liter per second. Okay. Now let's do a couple things here. Let's round this to 2 sig figs. And just report it in molarity per second. And we're talking about reactant B. Now remember, we said that this substance decreases in concentration. So let's put a minus sign here for the reaction rate. The reaction concentration of B is going to decrease by this value every second. Okay? So let's go ahead and just box that up, make a note here. That's for B. Now we do the same thing for the other chemical involved in this reaction, A. So 0.025 moles of C per liter times second. Okay, and we use the coefficients to do the mole-to-mole conversion. There's 1 mole of A per 2 moles of C. Moles of C cancels, and we're left with 0.0125 moles of A per liter per second. And let's just round this to 2 sig figs, 0.013 molarity per second. Okay, and A is a reactant, so it's going to have a decrease in concentration. So let's put a minus sign in front of that. So that's how you do this problem. Thanks for watching.